For next question, it's asked what percentage of the kinetic energy of a moving particle is transferred to a stationary particle when it strikes the stationary particle or four times its mass. So let m1 be the mass of the first particle moving with velocity u1, and it strikes the second particle of mass four times the first mass, and it's at rest, so its velocity is zero. Now we have to find the percentage of the kinetic energy transferred to this. So let its final velocity is v1 and its final velocity is v2. So what percentage of kinetic energy of the moving particle? So its kinetic energy, let's say its kinetic energy is k, and its initial kinetic energy is half m1 e1 square, and its final velocity is v2, so its final velocity will be, let's say, k dash, which is half m2, so its mass is m2, which is 4 times 1 into v2 square. So I can write it as k dash is equal to half m2 is 4 times m1 into v2 square. So this is 2, and k dash is 2 m1 into v2 square. So this kinetic energy is transferred to this kinetic energy, that is the initial kinetic energy of the first body is transferred to, because this was at rest, so this is the final kinetic energy of the second body, and we have to find the percentage increase. So let's use the law of conservation of momentum. So we are going to find out v2 and replace it here. So according to law of conservation of momentum, and we know that according to law of conservation of momentum, initial momentum is equal to final momentum. So this is m1 v1 plus m2 v2. Now this is mass m1, v1 is not known, mass m2 is 4 times, but it's, so this is 4 times m1, and initial velocity is 0. So this is m1 v1, m2 is 4 times m1, and this is the final velocity. So 4 times m1 is 0. Okay, so finally we have m1 u1 is equal to m1 v1 plus 4 times m1 v2. Okay, if we take m1 common in these, so this m1 is common, so m1 u1 is equal to m1 is common, v1 plus 4 times v2. So this gets cancelled. And here, so u1 is equal to v1 plus 4 times v2. Let's keep it as equation 1. And also for elastic collision, we know that coefficient of restitution is equal to 1. So for elastic collision, velocity of separation is equal to velocity of approach. You can write, so velocity of separation is equal to velocity of approach, and velocity of separation is given by v2 minus v1, and this is u1 minus u2. So u2 is 0, so this is v2 minus v1 and u1. Okay, now we are going to find out, let's get v1 here. So v1 is equal to u1 minus 4 times v2. This is 1, and we are going to replace the value of v1 here. So this is now v2 is equal to negative of v1, which is u1 minus 4 times v2 is equal to u1. Okay, if I go ahead and open this bracket, so this negative, this is positive, is equal to u1, and v2 plus 4 times v2 is 5 v2, and u1 plus negative u1, so this is 2 times u1, and we have the value of v2, that is 2 by 5 times u1. Now we have to find the percentage change in kinetic energy. So this is the percentage change in kinetic energy is equal to the initial kinetic energy of the first body upon the final kinetic energy of the second body into 100 because it's a percentage, so half and half gets cancelled. And now it's m1 u1 square upon m2 is 4 times m1, and we have to find the value of v2, which is 2 by 5. So this is 2 by 5 u1 the whole square. So this is 2 by 5 u1 the whole square into 100. Okay, m1 and m1 gets cancelled, so this is u1 square upon 4 into 2 to that is 4, 25, and u1 square into 100, so u1 square gets cancelled. This is now 100 into 25 by 16. Okay, 2, this is v2 is 2 by 5 times u1. So this is square of v2, which is 4 by 25, u1 square gets cancelled, 4, 4 is 16, and this is now 25 by 16. So we've got the value of v2, which is 2 by 5. So 5 times v2 is equal to 2 times u1, and v2 is equal to 2 by 5 times u1. So this is the change in the percentage change in the kinetic energy. Okay, okay. This should be actually because we have to find the percentage change in the kinetic energy. So this should be the final kinetic energy, and here it should be half m1 v2 square. That is the final kinetic energy of the second body, and this is the initial kinetic energy of the first body into 100. So this gets cancelled, and m2 is 4 times m1. Value of v2 is 2 by 5 u1, so this is 2 by 5 u1 the whole square from to u1 square into 100. This gets cancelled. Okay, so this is 4 into 4 by 25 u1 square upon u1 square into 100, and this is 16 by 25 into 100. So 25 4 is 100, so this is 64%. So 64% of kinetic energy is transferred to the second body at the rest, that is which is 4 times the mass of the first body. Thank you for watching.